In rapidly developing countries like India, where cars on roads are growing exponentially, but infrastructure being age old, traffic is a huge problem. For example, approximately 20% of all driving time is just spent on standing on red light. Big infrastructure changes, like flyovers and highways, will take years to develop. But how can we start small and solve this challenge through modern technologies like AI and machine learning? And that's what we do at Flow.ai.
So what are the problems we found? It might have happened with you also, that you have to stand on traffic light even though the road is empty. And sometimes you have to wait twice or thrice before your chance comes. This is because there's no real-time traffic light countdown system, which leads to inefficient traffic control models, which result in impatient drivers, breaking rules, and often getting into accidents. Also, there's no system to prioritize emergency vehicles on red light, due to which a lot of ambulances and policemen get struck. For the proof of concept, we conducted a survey of more than 100 plus participants. And when we asked them that does it happen very often that you have to stand on traffic signals even if it's an empty road, more than 50% of them complain about this inefficiency. And we got a mind-blowing percentage of 90% who felt that there's a need of smart traffic light system. So what are the existing solutions which we have? There are some rush hour predicting timers which are being manually set by policemen, and these are very unreliable. And that's why it doesn't add much to the existing cause. Moreover, there are some CCTV cameras which are being managed by control rooms in remote locations such as Delhi and Bombay. But these two, in my opinion, are a sheer waste of public human resources because there's already a huge shortage of number of policemen per 1,000 people, and this even adds more to it. And then we came with our solution. What if we add AI to traditional CCTV based traffic control models and make them smart AF?
Alright then, how do we go about this? We first use a machine learning algorithm to analyze the images. We process them, we set constraints for the minimum possible red time and emergency vehicles, and finally we predict the best possible solutions to get the traffic cleared in the shortest time. Computer vision is at the heart of our technology. We use image processing algorithms to determine a parameter that may serve as a good measure of the traffic. So let's say the traffic density of each road. We use certain markers such as the blinking lights on ambulances or police vehicles to set them apart. And finally, we use all this data to come up with a solution that is the most efficient to get the traffic cleared in the shortest duration. Pre-existing data helps us to find certain known constants such as the average time in that area for the traffic to get cleared once the green signal starts. Also, due to the varying traffic levels at each instant, there is a possibility that the best solution may keep varying at every second, let's say, and that makes the traffic solution very erratic. Thus, we ensure that there is a minimum period of time until which the timer has to remain at a set value, and only then it can change. Also, sometimes the best possible solution may not be feasible. Like, it's not good to have a 1 second red light timer, right? Even 5 seconds for that matter. So we set limits, lower and upper limits, so as to ensure that the solutions are practically acceptable. Here's a great example to voice out the benefits of our solution. Each dot represents a certain number of cars, and I've taken the average rate of clearance of one dot as 1 second. The fixed time solution does not look at the traffic on each street, and so it wastes a lot of time. For instance, the 60 seconds of road 1 of round 2 are of no use, right? Because there are no cars on that street, while all the same, the cars on road 4 have to wait for 60 additional seconds for no reason. So our timer analyzes the traffic, adjusts the timers accordingly for the red light on each street, and thus we gain around 50% time saving.
Ours is a unique selling proposition. It is cost efficient as it does not require heavy technologies, expensive cameras and gadgets. It just requires the data from the existing CCTV cameras to run on our AI servers and send the instructions to the modified signal. What about the safety protocols? Answering to that, we have ensured all the possibilities of the cyber attacks and we have contracted with the robust security systems to ensure the cyber security. We also have some kinds of time constraints to be sure that there is no kind of huge fluctuations between the time intervals. And in case of system crash, which is very rare, but if it happens, we have all kinds of protocols such as maintaining a backup and a provision to switch back to the traditional method for the time being, and the system can be repaired again.
So, what our future plans are? Real-time traffic light system is just a start. Eventually, we want to create a new smart traffic controller. Also, to add AI and ML existing CCTV cameras, prevent accident and crime. Also, we have advanced traffic flow management. By this, we will control the real flow of whole city by manipulating traffic lights. And who are our target markets? We will be selling to the central and state government of India, as well as traffic control boards of developing countries abroad, since already developed countries are not at our market.
This was a presentation by Group 109 for NIN100 course. I am Shashank Choudhary from Department of Biotechnology and Biochemical Engineering.
Hello everyone, I am Vora from the Department of Computer Science and Engineering.
Hi guys, I am Yaswanth from Mechanical Engineering Department.
Hello everyone, my name is Tushar Chandel. I am from Department Mathematics and Computing.
And thanks for watching our video.